Today, most companies in your supply chain are likely to be using CAD systems for their product design. In this ebook, industry analyst Chad Jackson describes how recent CAD innovations improve the productivity of designers and engineers who work with multi-CAD data. Today on Engineering Newswire, brought to you by PTC, delivering technology solutions that transform the way you create and service your products. We're kickstarting low-cost robotics using a 3D printing vending machine and having a cup of coffee in the sky. Since November 2010, Annika O'Brien, the founder of the LA Robotics Club, has worked with enthusiasts interested in amateur robotics. Annika wanted to create a low-cost platform for building small robots that was flexible enough to work with different form factors, but powerful enough to drive sensors, motors, and relays. She turned to fellow makers Rob Newport and Brian Chan, who designed an ultra-low-cost development platform for micro-robotics that can be easily assembled with through-hole components and a soldering iron. The kit needed to be rugged and durable enough for real-world applications like robotics, aquatics, and competitive robots, and it needed to be small and lightweight enough to be used in aerial vehicles. After the prototype was completed, Annika turned to crowdsourcing website Kickstarter.com with a simple $1,000 goal to help create this platform for future open source robotics club projects. With 3 days remaining, Annika has raised more than $17,000 from more than 500 backers. At first, the group of volunteers was thrilled at the project's success when one simple fact reared its odd-shaped head. Who's going to mail all of these kits? If you're a backer, it's likely that your kit will be shipped to you from the same people that helped design it. Hey, it wouldn't be a grassroots effort without engineers subbing in as assemblers, shippers, quality controllers, and even secretaries. For now, Annika is figuring out logistics, but the way she envisions it, her living room is likely to resemble an Amazon processing factory for the next week.
We all deal with stress. Some of us are better dealing with it than others. Me, I have my own outlets, and taking a deep breath is not one of them.
So Megan.
Seriously? However, UK scientists have developed a new kind of stress test that can determine a person's stress level by analyzing their breath. During the study, test subjects sat comfortably while listening to soothing classical music. They were then required to perform a paced auditory serial addition test, which is designed to cause psychological stress. The subject's blood pressure and heart rate were monitored throughout this process, and breath samples were taken before and after each activity. Scientists found that the chemical content of those samples changed during both stressful and easygoing activities. They hope to one day create a standard testing procedure that will let caregivers know when non-responsive patients are experiencing stress. And who knows, maybe one day we can develop a sensor that lets us know when our stress levels are peaking. Until then, we're left to our own devices.
Both professional engineers and layfolk are making strides within the maker community. And if you're an engineer that loves your profession so much that you can't help but bring work home, desktop 3D printing is essential. But what if you don't want to foot the bill for a desktop 3D printer? A group of Berkeley students found it difficult to get quick delivery of 3D printing creations from online vendors, so they developed the concept of creating a network of local, automated 3D printing vending machines. Remember those injection mold models at the zoo? Dreambox is kind of like that, only it's a 3D printer and it uses uploaded CAD designs. Basically, users will be able to choose an existing design from an online catalog or upload their own via an online interface, set the machine in motion, and then receive a text message when the object is ready for pickup. Upon completion, a unique unlock code is entered and the 3D printed object is retrieved from a drawer. 3D printing can also be ordered at the machine via a tablet interface. Any custom creation is deleted after printing to prevent IP from being used without permission, but that may change to allow customers to store designs for later recall. The average print will cost around $15, but can be as little as $2. Of course, pricing is dependent on the material and the type of printer within the closest vending machine. While the current prototype makes use of a MakerBot replicator, the company is hardware agnostic and is seeking vendor relationships to ensure the latest technology is used in Dreambox machines.
If you're skiing at the Pitzel Glacier and you need a moment to get a cup of joe to help get warm, you're going to have to make a stop at Austria's highest coffee destination that sits high atop the glacier at 11,000 feet. Just how the heck do you get up there, you may ask? The visitor center, which was designed by an Austrian architectural firm, features a free suspension outdoor terrace that is accessible by a new 61 gondola monocable ropeway. The cable ropeway took 18 months to build for a whopping $27 million. The 61 working gondolas transport more than 2,000 visitors per hour over a distance of 1.24 miles and to an altitude of 1,900 feet in only 5 minutes and 40 seconds. The 8-person gondolas also feature heated seating and enough space for users to carry their skis and snowboards with them, making getting in and out significantly easier. The cable car complex is open all year round, but be careful when you get to the top. You don't want to miss your step while standing in line for a cup of Java.
As 3D printing makes itself more available to the world, new materials and uses continue to emerge. Osteofab is one of the most profound materials that you hope to never use. This new polyketone developed by Oxford Performance Materials can be used by 3D printers to repair large sections of a damaged skull, and it has been recently cleared by the FDA. A typical user of this material would be a car accident victim or somebody who has suffered serious physical trauma, specifically to their noggin. Here's how it works. In the emergency room, a doctor stabilizes a patient and gets a CAT scan. The engineer team builds on the data from the scan and creates printable CAD files that feature screw holes and scaffolding necessary for implantation. After surgeon approval, the design is printed using Osteofab on a selective laser sintering 3D printer. After quality control, the part is sterilized and implanted. Though expensive, the custom-built implants make surgery quicker, which saves money and can help reduce the chance of complications. The creators believe that the Osteofab technology is a highly transformative and disruptive technology platform that will substantially impact all sectors of the orthopedic industry.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For PD&D TV, I'm David Manti, and this has been your Engineering Newswire.